We're going to shift gears just a little bit for this presentation, but essentially stay on theme with a lot of things you heard today. And that is looking at the impact of tomosynthesis, particularly with respect to the radiation dose theme, as well as the underserved areas theme. Now, most of us in imaging know there's a long history with tomosynthesis. It's been used in musculoskeletal imaging, has a long proven history in mammography, but these tomosynthesis systems were relatively bulky, relatively expensive, and really, don't have a huge amount of utilization in day-to-day practice. You can see from this particular set the value of tomosynthesis. It's essentially a middle point between a planar X-ray and what you can see, and that's showing a fracture on a CT scan, albeit with many, many fewer images. In this particular case, you can see the fracture nicely compared to the X-ray, where you probably would need an AI algorithm to pick that out. You can see on the tomosynthesis images, it's really easy to see the fracture planes, and it really brings things into clarity. One of the additional, you can see from the right-hand side here, the fracture is relatively easy to see, and you can see the fracture there. One of the things you should notice about tomosynthesis is it doesn't suffer from the photon starvation, the streak and beam hardening that goes along with metal prostheses. Now, here's an interesting case with the light shining in my face. I can't see anything, but let's just say on the left-hand side, this patient with 3 compression fractures, it would be very, very hard to pick those out, and that might go unnoticed. And as you know, particularly in the older population, there's a high morbidity and mortality from compression fractures. If you look at the CT scan, then you can pick out a few. Where's the magic Belinda here? Belinda, there you go. There's a few fractures there. You can see the end plate fractures, but actually you can see them quite nicely here on the tomosynthesis really nicely. So invisible here, see them easily here, but you can also appreciate them there on the tomosynthesis. And that's just really the nature of tomosynthesis. So where does it fit into this particular concern that we're here to talk about, and then lung cancer? Well, when looking at potential lesions on a chest X-ray, the use of digital tomosynthesis avoided the need for CT in 75% of cases of this paper published in 2012. It is also useful in working up lesions in so-called the hidden areas on a chest X-ray. Behind the heart, next to the diaphragm, at the lung apex, all of those different concerns where you might be missing things. It has been proven to have value. When compared to tomosynthesis when tomosynthesis is compared to chest X-ray in a meta-analysis published in 2016, really helps to have my glasses on and my eyes working. You can see there was substantially better sensitivity and specificity of the tomosynthesis device. Now, there's an Italian observational study where digital tomosynthesis had a comparable nodule detection rate to CT. It's not CT, but a comparable detection rate, and could in some settings be used as a first-line cancer screening tool, particularly in those where there's one CT scanner for every 1 million people, I would think. But also in some offices and other settings where CTs don't usually exist. Now, in terms of how it performed in a long observational study out of Italy, it had a remarkably high concordance with the binary classifications that occur in lung rads. So, overall, digital tomosynthesis, it's better than a chest X-ray. It has a comparable lung cancer detection to CT. It concorded well with the CT and lung rad classification, and it is a promising lung cancer screening and management tool in certain settings. Now, the reason we're here today is that there is a sort of more modern, more acceptable, more adaptable version of tomosynthesis now available in this Nanox ARC. What makes this different is that these are, it uses multiple X-ray tubes arranged in an ARC. They are low cost. They need less power, they generate very little heat, and they're a much smaller footprint. So essentially, they're much more practical and have a better possibility for access. Compared to X-ray systems, they have a much lower power supply and a much lower power supply than CT systems. And they're much, much lighter. I mean, a CT scan typically weighs 2,000 kilograms. an X-ray system about 600, and now you see this is only 350. So it's smaller, it's lighter, uses less power. You can see how all of these things are pointing to untraditional settings. When it comes to the radiation dose, which was a big concern here earlier in this session, a chest X-ray typically averages around 0.1 millisievert. A chest CT, as you saw, the definition for low dose CT is less than 3 millisieverts. Lots of variables there, but you see the 3D digital tomosynthesis is running at 0.2, very much akin to what you get with a chest X-ray. Just some examples: X-ray on the left, tomosynthesis on the right, and you see there's that large nodule. So here we go. You'll see it coming up in the retrocardiac region, how nicely that the tomosynthesis brings up that nodule. Here you see a little nodule, very easy to see when the tomosynthesis is very hard to see on the chest X-ray. Here you see the arrow pointing to a tiny little nodule, but you really don't see, and you certainly don't see that on the chest X-ray, but you'll notice that when I bring up the tomosynthesis on the right side, there are two areas that there are nodules here and here that are hidden behind the hilum and hemidiaphragm that come out on the tomosynthesis that correlate with the CT. Okay, one last slide. This ARC configuration from Nanox, it was compared to linear tomosynthesis, and it was done with a focus on, potential physiologic motion. And this study showed that it was less prone to motion and improved lesion visibility with up to a 2 times improvement in contrast to noise and structural similarity imaging matrix. So, the bottom line is this is a technology that is available. It is now more practical and lower cost than it's ever been beforehand. It could potentially play a role in lung cancer screening and management, and it might increase the incidental detection of pulmonary nodules over chest X-rays, especially in alternative non-radiology settings. Thank you for your attention.